Welcome back. In today's video, we're going to create the FLTK wrapper for quickjs. So we are going to basically create the desktop app using the FLTK and using the quickjs. But there is a catch. quickjs is JavaScript engine that does not have direct access to C level. However, there is library called quickjs-ffi, which is for foreign function interface, which is intended to be used as interface between the JavaScript and C world, and the libraries built with C. In this case, the shared libraries. That's number one. Number two is FLTK is written in C++. So we'll need to use C wrapper of FLTK and then use the quickjs-ffi and then use all of these inside of quickjs. So because there will be automation required, there are quirks, there are a lot of things that you need to know. I will create the repository, and in this repository I'll basically host all steps and all source code and all examples and everything. Feel free to fork it to build the official project. This is just the proof of concept, how you can use the JavaScript, quickjs in this case, and to build desktop apps. That's all. And also I'll show you how you can compile JavaScript to executable files, so they can be just distributed as they are. So without further ado, let's go. All right, so how are we going to call this repository? We'll call it quickjs FLTK, maybe or quickjs like this. quickjs FLTK. Yep, that's fine. quickjs FLTK. It'll be public. README file, ignore. Thank you. I like to use C. Actually, let's go with C++. Probably has more ignores than C. Choose a license. Yep. I would like to use BSD simplified license. Yep. Create repo. Clone. CD projects. Okay, so we are going to add other repositories as submodules. First one is quickjs. Go there. This one. Copy. Git add submodule. So we just say git submodule add, and that's it. Yeah. Git submodule add. That's it. That's number one. Next thing we need is quickjs-ffi. Which one? With this. Yep, that's the one. Copy. Give some git submodule add, and we will add also this one. All right, now we need something called cfltk. All right, so FLTK is fast light toolkit. This is how it looks like. You can see some demos here. All right, so we can quickly build the UI. Can customize it. I see also it's running on Android now, which is really nice. View widgets, you can adjust style and everything. So it's like what you expect, but it's written in C++. We cannot interact with C++. We can interact with C. So thankfully, there is something called cfltk by user Mo Aliosif, if I pronounce this correct. So he also has two submodules, FLFlex and FLTK. FLFlex is like flex display in HTML, CSS. Yeah, it's inspired by Flexbox. That's great. And it's intended to be used for easier GUI composition, whatever. So you're more naturally, you can build apps. All right, we don't have to care about that stuff. We can just have as a submodule this one, and these will be recursive submodules. Okay, code, copy, and then git submodule add. All right, so let's see instructions here. All right, we'll need this. So I'll start writing instructions, what you need to do. Let's go to this size. Build first bash git submodule update init recursive. This is first time you actually clone. So after you clone, actually let's write also these instructions for you as they did. So git clone cd this one, then you'll execute this command and you'll get everything you need. That's great. Also recursive repositories. Awesome. So we have quickjs, quickjs-ffi, and cfltk. Let's start with quickjs. cd quickjs, just type make, and that's it. You wait until it's built, and it takes probably a couple of minutes. QuickJS is really lightweight JavaScript engine. It supports ECMAScript 2020, which is like probably one of the most advanced, if I can say, yeah, specifications of the language. If you use ES 2020, you basically use modern JavaScript. But be aware, when you use a QuickJS, you don't have IO libraries, for example, or you don't have asynchronous stuff like set timeout or set interval or stuff like that, like timers. So you have to implement this on your own. You don't have a library for interacting with the network. Thankfully, there is a combination of QuickJS and libuv. So if you type quickjs libuv, it's called QUV. This is an experiment of using libuv as the platform layer for QuickJS, and basically you get TCP/UDP sockets, TTY handles, Unix sockets, name timers, signals, basic file operations, event loop. All right, so event loop is the key thing. So you need event loop if you want set timeout and end timers, and set interval. High resolution time, miscellaneous utility functions, worker threads. This is if you want multi-threading, child processes, if you want sub-processes, DNS, and so on. So, and also text encoder and text decoder APIs. These two, you won't believe how many like libraries depend on these. So what I end up doing, I just come here and I get it from depths, I guess it was here. It's usually somewhere here, and I use it for my other projects where I need it. I think actually it's in encoding. Never mind. You get a point. You just get what you need. This is open source. Okay, quickjs is built. So let's just test it. 1 plus 2 equals 4. Okay, so we have quickjs working. Now we need, let's open another tab. Let's go to quickjs-ffi. Also just make. All right, so it needs quickjs as system-wide include directory. I don't want to do that. What I will do, I will edit make file. So I'll introduce something called cflags, and I'll just say -I go one step backwards. So here, so this one will act as one of the system included directories, and quickjs will be immediately there, and quickjs libc and quickjs age will be visible to quickjs-ffi library. So still I have to do some stuff here. So everywhere you see GCC, you can do this. Great, let's now try to make, yep. Oh, it worked, nice. So we have quickjs-ffi so. What now? What now? Now we'll need to go to cfltk and instructions for that one. Clone, go inside the update submodules, great. If you use Android, go inside. No, I don't use Android. Configure. I remember there was extra configuration below. Yep, here. So I'll use this one instead. Why I'm using this one? I want some control over the configuration options, such as I want it to be release. I don't know what's by default. I don't want to use the system lib, PNG, encoder, decoder, lib, JPEG, zlib. All of these will be. They have. I think FLTK has its own implementation. I don't want to use a OpenGL for now. FLTK build examples, no. FLTK build tests, no. Option use threads, yes. Option large files, yes. Option build HTML documentation, no. HTML build PDF documentation, no. Yep, that's what I need. So it's configured, and right now to build, we need this command. And that should be it. I'm aware that FLTK by default only builds by default, it only builds the static libraries. You see, this one is static. Lib sfltk, so on. So you have to statically link. We need shared link because we want it to be used by quickjs-ffi, because this one actually can interact with the shared libraries. In other words, we also need to build SO file. So if we don't get the shared library, then we'll have to change something. Pay attention here. It said in the linker it's shared and it's position independent code. We'll need that as well activated here if it's not. So we have fluid, which is builder, graphical builder for apps. We have static for forms, images, FLTK, yep. But I don't see shared library, no shared library. All right, so now what we need to do, we need to edit some options or add some more options. I'm not expert for CMake, but I know some stuff. So cfltk shared by default is off. All right, so go back to configure. Now I'll say, actually, let's go to next line. On, and there's extra stuff. I want to make sure about something. So I need flags. This one is first. So CMake 6 flags dash FPIC pick. Also there is C flags. Same thing, FPIC. And one more thing, we also need to make sure that linker knows about this. So yeah, interlinker flags, yep. Now with this, hopefully we'll get the shared library with the position independent code, whatever, configured correctly. Let's rebuild it. Yep, you see, here is this is the shared library, and it says shared library. This file, that's what we're looking for. Great. Check something. So if I go to source, include, this is what I care about. Window. Actually has a GL. Let's reconfigure and rebuild with the OpenGL. Support on. So only this one on. And let's rebuild. Every modern system supports GL. I think the GL is the most portable graphics library ever. Excellent, this worked actually. Super cool. Okay, so now I'll go to quickjs-fli. Let's just go there and bin. Yep, that's the file. We need that file. Okay, so I will copy this file. libcfltk so152. It might be something else. This one is just link. So let's create folder called quickjs. No, actually, let's have it here. I'll just copy paste it here. Yep. Then we will need the quickjs, this one, and the compiler. These two are executables. And I will need 2 more files, quickjs-ffi.js, which is JavaScript wrapper for quickjs-ffi.so, which is C module that can be imported in quickjs. Great. Close, close, close. Where we are. So we have quickjs interpreter, which is like 4.7 megabytes, compiler, which we can use to compile JavaScript to standalone executable. We have a libcfltk, which is C wrapper for FLTK and shared library, and then we have the quickjs-ffi that we're gonna use to interact as a bridge between quickjs and the libcfltk. In this case, FLTK. So let's just try just to see if quickjs works. It works. That's fine. That's for me enough. Okay. Now let's write first the test, and let's call it. Let's actually see how it's called. If there are any tests, examples. Hello. Yep, there is test. So we're gonna retype this test from C to JavaScript, and it's called hello. It's good. So hello.js. Now I will need to consult my little friend called quickjs-ffi. So they have some examples. Import this. Let's see if this one is going to work. Quick.js, then hello.js. Perfectly. Works. Then we'll go and wrap one by one these functions used here. And I'll also go into header files and find their signatures because I need them for this place here. First one. First, cfltk button image widget window. Basically, they tell us which header files we need to open. FL init all is in cflh. Let's go there. So this one first. And we'll use const because there are not change. All right, so we also need to specify which library we used. So libcfltk will be this one. Copy paste libcfltk, and then I don't want to just repeat. We'll use the. This is constant as well. Constant. Then we have to specify number. We don't have to specify number of arguments. It can be null because it'll figure out automatically. Let's also enable word wrap, so in case we go to another in here as well. FL init all. So that's void and void. Basically, we just have to specify void. And since there are no void means no arguments. It's same like this, but it's safer to be void in C. We don't have to specify void, just void for the return. Excellent. Then we have register images. And register images is in CFL image. And then also void, same thing. Then we go to lock. And lock is in CFL age, int and void. So we just have to say this is integer. That's it. Next one. Okay, now we have FL window new, and that's probably in the CFL window here. window declare. Hold on, this is meeting with. Oh no, that's macro. So they use macros. Here is new. So new returns pointer to widget. I don't care what's the type here, just care it's pointer. So I'll just say it's pointer. Then we have argument, the parameters, integer, 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 and then we have constant char star. This is string, so we have 4 integers and 1 string. So int, so xy width height, and that's this xy width height, and we have string at the end. Excellent. String. What we have now, we have new button. That's probably a button. There is no new. Yep, again, macros. Yep, this is the same macro used also for the FL button new. So it returns the pointer to something, then it has integer, 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 and string in the end. Great. I don't have to change anything here. I really don't care what kind of widget is here at all. Yeah, I just need to know that's pointer to something, and that's it. Now we have FL window end. FL window end, that's probably also macro. And yep, we have void and pointer. That's it. So void and pointer. That's all. Now we have FL window show. It's probably again the same thing. Macros show. Show, that's void and pointer again, same thing. And we have this one. I'll cover it later. I don't want right now to connect any callbacks to buttons. When I click the button, something happens. I need FL run to actually run the app. And I guess it's void and integer since this one returns integer. So it's integer and nothing here. It's just integer is returned. But let's check FL run. It's in cfl.h. Yep, integer and void. That was easy guess. And now, since we've wrapped all of this, we're going to write this function main. That's it. Code goes here. These functions are invoked differently using so you see when you get the function from the shared library, it's invoked by function.invoke, and then you pass the arguments. Great. So invoke, same here. Now this is the name of the window, so I'll have it hello something, hello. This is const, or it can be let as well, doesn't matter. Let window invoke, let be FLB window invoke. So this one have click me as a text. Invoke, we don't use this one right now. Return that and also invoke. So Fingers crossed, when I call this code, it should run the simple graphical app, written in FLTK. So it says it's not a function. Hello.js 18. Oh, here the lock. I forgot to invoke. Try again. Whoop! It worked. Here it is. Hope you can see this. That's great. Nothing happens when I click and click. Let's support that as well. So they have this function called cb void function. I don't care about this. I don't care about that. I need this function. I don't have that function. So fl widget set label, get probably in macros. Yeah. It has a, it's a void. Set label, void, then pointer, then string. All right, so void pointer string. Makes sense. Also invoke. Also I need this one. Button set callback. That's probably here as well. Set callback, yep. That's void pointer pointer void pointer void and 3 pointers. Void pointer and the pointer. Okay, so now somehow we have to say that we pass b is like pointer, cb is we cannot pass a JavaScript function as argument here to C function, and we cannot pass null, so I'll just pass 0, because instead of null as a pointer, if you want to pass, you cannot use null here. It has to be 0. I know that because that's how quickjs-ffi works. Let's see. This is pointer to a function. That's exactly what we need. Yep, it's called the C callback. We can actually import it here. So I can say right now, let cb equals new. Then we pass JavaScript function. Then the number of arguments, null. And then we specify these two arguments. So this is pointer and pointer. And what returns, what this function returns, let's see, it's void. So it's void pointer. So right now, I don't think, so this is some kind of C callback but we need pointer to that thing. So let's see how that's done. Create callback. Oh, C funct. There is actually, yep. So we need to do this. Just that. That's it. Or I can do it actually here. So it's immediately the pointer it should be. Let's see if this works. Oh, it's shown a different screen. When I click here, it should change the text. Oh, it changed to works, but this is a little bit weird because I said change text to W, and W was window, but since I said invoke B is passed as W, Oh, that's why. So basically as data, I can pass. So this one is here. This one is what function I want to execute. And this one is actually data. So here I can say double. And here I'll say let, for example, bin equals data. I'll say bin. This is widget. It's actually it's no. Let's call it like this. So I'm not using this widget. I'm using data. Let bin equals data. Yeah, this should be it. Let's see if that works. So now when I click here, it should change the text here. Nope, it doesn't. Let me think for a moment. Void, that's what this function returns. Pointer, that's this one. Pointer, that's that one. And here let bin equals data. Let's say this one is win. I don't know. That's the problem. It doesn't work. Let's see if I say still works. Yep, this one works. But what about widget set label? Maybe it's called Windows set label. Where is window? Window. Declare FL window. No, maybe it's window. Yep, that was it. That was easy. So window, so we'll say hello world. So basically when we click to this button, it'll change hello to hello world, ampersand, and click me to works. Yep, it works great. This was really awesome. I'm really happy with the result. Oh. Hello.js. Git commit. Working. Works. Push, so I'm basically working on main branch. I really don't care right now about the branches. Let me show you one more cool thing. So basically I can compile this hello.js. If I do quickjs c hello c. Oh man. It says it requires quickjs libc. All right, so let's do this thing. Let's go to quickjs and then quickjs and then hello.js. Great, we get output called a out. I'll rename it to just hello. So right now I just need execute hello and that's it. It's single executable file, but I still need shared libraries. So basically, let me show you what you need. You need this. Let's call examples. Hello. So we need hello, this one, that one, and that's it, I guess. These three files. So if I open terminal here, I say hello. Yep, that's all we need. There you have it. In total, under 10 megabytes, everything. So one executable file, one shared library for FLTK, C wrap with C, and then we have the FFI foreign function interface to interact with that library. Okay, what I don't like, there are a lot of things that I don't like right now, and I want to fix all of them if I can. First thing first, basically I'll remove just examples. I don't care. Or I do. Do I care? I'll remove it. So what I don't like is this. I don't like this stuff here. So this should be called something like this. Const equals, that's the function that calls this one with invoke. So I can just, I don't need this invoke. I really hate that. Same here. For this one. Oh, yep. You get a point. One of the things is, okay, so we've wrapped basically two of them. Let's see if it works. Yep, it works. It works. This one is a little bit, so that's window new. Const equals invoke, and then I think it's called arguments. What about the function where arguments? Just call arguments, yeah. Oh, this one, that's what I'm looking for. So args, args, and I guess here it's just also args. Let's see, maybe that's the one, maybe that's not. Set the window, yep. Also, let's fix this one while we are here. Most. And we don't need this invoke. Alright, so that's it. Yep, it worked. Excellent. That's all we needed. Get the variadic number of arguments and also pass them there, extract, expand. I think the correct term is expand. Same thing here. Wow, that's great. Cool. What we can do now is can basically go and parse all of these files and automatically create these wrappers in JavaScript. So parsing these files, I can automatically do that. All right, for now, I'll just end video here. Here you have your first quickjs FLTK hello world example working. You saw how I bridged the quickjs JavaScript world with the C world using the FFI, and I wish you good luck using these technologies. Thank you for watching and see you soon. Goodbye.